All right, so how about writing text to files? Pretty much works the same way as writing to the screen. The only difference is that you're going to first open the file, and then you're going to use print writer or stream writer, depending on which language you're in, to actually put each line in there. And you do it line by line, just like you do on the screen. So you could have a while loop that prints out all the different lines. All right, so here's an example of writing a file. And again, we're in Java. You're going to import java.io. And we start off and we have a file called myFile, and that gets a new file on output.txt. And then we have a print writer, which we're calling PW, and that gets a new print writer on myFile, which is what we just made right here. And then we just print to it. So printwriter.println, printwriter.println, and at the very end, printwriter.close to close the file. Okay, we didn't actually close the file in the other example, and you should remember to do that. There's actually a comment down here that says you should have done that. We didn't do it, but you should do it. You simply call close, which is either lowercase c or a capital C, depending on which language you're in, on the object where you opened the file. All right. And I said that wrong. I said it was on the object that you open the file. It's actually on the print writer object is what you close here, not the myFile. All right, sorry about that. All right, over in C#, pretty much the same thing, except instead of print writer, it's stream writer. And so we open up a new stream writer on the file, streamwriter.writeLine, streamwriter.writeLine, and we have the catching of the exceptions and streamwriter.close, the same thing. So, I mean, honestly, that code is identical, except you're changing the word streamwriter to the word printwriter. But other than that, I believe it's identical. And, okay, printline and writeLine. So maybe not exact, but there you go. And again, you have to remember to using system IO, otherwise this will not work. All right, if you were dealing with a binary file, which could be an audio file, it could be an image, it could be a PDF, it could be a Word document, an Excel document, or it could just be some random binary file that's in some random binary format, then you're going to have to use the lower level ones. You can't print line or write line with binary data. So you would use binary writer and binary reader in C#. All right, so here is the example of that. And in this case, when we open the file, we're using file stream as the object method. Again, it takes one parameter, which is the name of the file, and then you have to specify what mode you're trying to open the file in, which is either going to be read or read write. In this case, we're opening it as a create, so it's going to create the file as a writable file. And then binary writer gets new binary writer on that file. And now we have a byte array, which we are just opening up an array of bytes. And we're going to put some random stuff in there just so that we have something to do. And then we're going to write that. So that happens with binary writer.write. We pass it the array and we tell it where we want to start and where we want to end. We want to end at cell 1000. All right. And if there's a problem with any of that, we catch the exception. So that's writing a binary file. Honestly, writing a binary file is the least common of those. You'll more often be dealing with text. Okay, so general software engineering tip, anytime that you open a file, you need to get in the habit of closing it, and you should close it as soon as you are done with it. So the moment that you're done writing to the file is when you should close it. You will learn this lesson the hard way. If your program crashes at any point during writing a file, it's possible that what you get is nothing, even though you may think you have written a bunch of stuff to the file. Why? Because everything that happens with a file happens with a buffer. And I'm going to explain that in a little bit more detail in a moment. But trust me when I tell you this, when you are done dealing with a file, the very first thing you should do is close the file, which will have the effect of flushing the buffer and getting everything into the file and then closing the file on the file system. So you may have hundreds of files that you're dealing with. It's not uncommon that you might need to read in 1,000 files off the file system and write another 1,000 files in response, or read in one file and write 1,000 files out. Think of reading in every student's grade from test 1, and then another file for test 2, and another file for test 3, and another file for the final. Yes, I know there's only 2 tests in the final in this class. That might be 4 files that you read in, but then you might want to write out a separate file for every user that has their grade in it. So in that case, you would end up writing out, for this class alone, 130 output files. So again, as soon as you're done with each file, close it. Very important. Don't know what else to say about that. So good practice, get in the habit. If you do not close it at the end of your program, assuming your program did not crash, it will close it for you gracefully. But again, that's a big assumption that your program didn't crash. The other thing I will say here is that I've mentioned that there is standard input, which is your keyboard, and standard output, which is your screen. There's also another magical thing called error device, which is also your screen, but that's where errors go to, and none of those should ever be closed. You can call close on them, don't do it. Okay, so let's talk about buffers. And I'm going to recall a story for you when I was in college. This was back in the year 1772, I believe. And I was learning to program in C. And I wrote a program, and it was not doing what it was supposed to do. And so I started adding in debug statements. I was very new to programming C at this point. I started adding in debug statements, so I'm doing some prints in there, and I'm basically trying to see, is it working? Like, I have a loop, and every time it goes through the loop, it's supposed to print something out for me. And it wasn't working, and I wasn't even getting the print statements. So I spent all night, and I literally mean all night, before an assignment was due, trying to figure out why my loop wasn't working. And at about 6 o'clock in the morning, I passed out. And when I woke up at about 8 o'clock in a panic, because of course this was due at 8:30, I suddenly realized what the problem was. And the problem was that the print statement, I suddenly realized what actually happened was I think I called somebody and they told me, you're an idiot. The print statements are being buffered and they're not being printed out. And I said, what the heck is a buffer? And they said, just trust me and do this. And then magically it started working. Okay, so cool story. Why am I telling you all this? Because buffers will eventually drive you crazy. When you print to the screen doing a system.out.println or a console.write line, you are used to the fact that it happens instantly. The moment that that line of code appears in your code and executes, boom, it appears on the screen. And that's because the screen is flushed very often. Every time you do a print line, it actually will flush the screen for you. It does not do that to the file. It will flush whenever it feels like flushing. What are we talking about here? So when you write to a file, what's actually happening is you're writing to a file buffer. And every now and again, Java or C# will decide now is the appropriate moment to actually write that out onto the file. Why? Because it's very inefficient for the program to actually interact with the disk constantly as you're telling it to write. It turns out that that's really, really slow. So to speed things up, rather than doing it in real time, what it does is it writes it into a buffer. And then when the program is not very busy and the operating system is not very busy and the hard drive is not very busy, at that moment it will attempt to flush it out to the actual hard drive and write it. This is why I said you could write code where you do an open on a file and a bunch of prints to the file, whether they be the Java or C# version, but you do a bunch of prints, and then your program could crash after all those prints have happened, and you could go look at the resulting file and find that there's nothing in it. If that happens, then you are in a situation where all of that data was written into the buffer at the moment that you did the print, but the buffer never actually flushed out there. So every time you write code where you're printing something out, one of the things that you need to do is you need to call flush, which in none of these examples did we actually do. We're going to do it in the next example that we look at, just to make sure that you understand that. All right? So make sure you get used to calling flush, and it just gets called on the same thing that you call close on. All right? So let's move in a different direction. I'm going to pop open two little Replit windows, and I'm going to show you a little bit of code that I wrote earlier. So in Replit, it is possible to make files that are not actual source code. You can actually just have files. So you can see this Replit URL. If you want to pause, you can write it down and you can come play with this the same as all the other Replits that you've seen in here. There's a Java version of it, and if I tab over, there is a C# version of it as well. Okay, so in both of these cases, I have added a file to the Replit by clicking Add File up here, and I simply named the file .txt. In this case, I would totally have said that there were numbers in there, so I'm going to reload that file because I think it's in a screwy state and it's not showing me what's going on. But anyway, this is just made up data. I obviously just completely typed in random numbers, which are supposedly student IDs, and grades, which are the grades from some test. Who knows? And so what I'm doing next is I'm going to make sure that that's also here in the C#. It is, there it is, and they are the same. I'm just alt tabbing between the two windows. One of them is Java, one of them is C#. In each case, I'm going to write a main function, which is going to take this data and it's going to tell me what the average of the scores are. So what it's going to have to do is it's going to start off with the cursor right where I have it blinking line up there on the top left, and it's going to read in one line of text using the read statement, whatever the read one is for your language. Then the cursor is going to move on to the next one. Once I have read in that line, I obviously have to do some work to break it up into two things. One thing is the student ID and the other thing is the actual grade. So I'm going to use that same split method that we saw in the previous example. And I'm going to store that number in a sum variable where I'm just going to add up all of the sums of all of these. I'm going to generate a sum of all of the numbers that are in here, and I'm going to count how many numbers I have. That's how you calculate an average. So it'll take the 100 out of here, it will add it to my running total, and it will increment my count so that I know that there's 1. Then it's going to add 92 to the running total, then it's going to add 70 to the running total. This poor person got a 0, so it's going to add a 0 to the running total and a 50 to the running total. And then at the end, it is going to divide the sum of all those numbers by 5, because there are 5 numbers in there. Okay, so that's what's going to happen. Let's take a look at the actual source code. All right, so let's do Java first for no apparent reason. So I have a public static void average grade, which takes in a file name, which is a string. I'm expecting that you will give me a string here. All right, and so I start off and I initialize my grade sum and my grade count. This is the variable that's going to hold the sum of all the numbers, and this is how many numbers I have read in from the file. So this should work whether there's 5 numbers in the file or 1,000 numbers in the file. All right, and so we start off and we open the file. So we're going to say grade file gets new file, and then we're going to pass it the file name, which came in as a parameter to this method. And then I'm going to use the scanner. So I'm going to call scanner.readFile gets new scanner on that grade file. Cool. And now I'm able to do has next line in a while loop. So I'm saying while the read file has another line, then I'm going to next line the read file, which pulls in a line and gives it to me in a variable which I'm calling student. So remember that has the student ID, comma, their grade. Then I use the handy dandy little split function, which is going to break that line up into two different string or into an array of strings, where the first cell is going to get the student ID and the second cell is going to get the grade. And then at that point, I call, just to make it easier for myself, I call the first one the student number. That's just pulling out mapping, which was the array name from up here. I pull out cell 0 and I store that as student num. And then I have to convert the other one because it's currently a string and I need it to become an integer. So I use integer.parseInt on mapping 1, which again was a string, and that gives me a grade. Down at the bottom, grade sum plus equals grade, grade count plus plus. I do print out the student and the grade just so I see it. And then I'm doing the very important readFile.close in order to close the file. I do have my catch just in case something goes wrong. And then at the end, I calculate the average by taking the sum and dividing it by the count, and I print it out. So hopefully all of that makes sense. I'm going to go ahead and run that. And I actually think if I move my window here, it is being screwy for some reason. So I'm going to refresh that, and I'm going to go over to the other window in C# and talk through that while that's refreshing. I think this one is in better shape. It is. Okay, so this is the C# version of that same code. Nothing here is really different. Again, I'm just using lowercase string for strings, and I'm using stream reader, which does both of the lines that I had to do in Java where I opened the file and then used scanner. So stream reader does both of those things for me. So stream reader, while grade file, which is that stream reader, is not at end of stream, then I do a read line, and then after that all the same. So this is the split to break it up into the two parts, and I get an array of strings called mappings. I rename, or I name student num, whatever is in cell 0. I print out what's happening. I convert the other string into an integer. I add it into the sum and the count, and I close the file. And then down at the bottom, I calculate the average and I do the print line effectively to tell me the grade. So down at the very bottom, we'll come back to the rest of the code that's in here, but down at the very bottom, you can see I call average grade and I pass it a file name, which is test1 grades, which is out here in that list. So when I run that, what you're going to see is, with any bit of luck, there are the lines from that file. And I'm just going to open up the file so that you can look at the file. So this is the raw file that it read in. And you can see when it read in the first line, that's the student ID, 12112, and that's the grade, which is 100. All right, and then it ran through all of these. It got the 100, the 92, the 70, the 0, and the 50. And just to prove a point, if you take those grades and you add them together, you would get something like 100 plus 92 plus 70 plus 50. We don't have to add in the 0 because obviously they got a 0. And I'm going to divide that by 5. You see that the average is 62.4, and it printed out average is 62. And that's because I didn't bother to deal with the fact that it's a float when I was reading in the numbers and dividing them. I set them up as integers, so it did integer division. If I changed them to floats, it would have been fine. All right, so that calculates the average correctly. I'm going to run back over to the Java window, which is still loading for some strange reason. And I'm just going to hit run there so that you can see it. It has the same call at the bottom, test1.grades, and life should be good. And I will get out the exact same output because, of course, it's running pretty much the same code. Cool. While Java's being Java, I'm going to come back over to C#. And just to prove a point, I'm going to name the file test2grades, which I do not have. And I'm going to try running it. And you're going to notice that I'm going to get my catch exception is going to happen. And my exception says unable to open test2grades system IO file not found. So if we scroll back up here, we can see unable to open info about, oh, that's not the right line, sorry. Unable to open, and then I gave you the file name. So that's where that is coming from. That is my catch that's happening there. The rest of it is because I actually printed out the raw object, which is the +e. You'll notice I didn't stop the method. At that point, it actually went on and tried to calculate this, which of course is an error. So that throws another exception because I'm going to get a divide by 0 because at that point, grade count is 0. So that was bad programming. All right. So that's all that. And just to prove the point that Java did actually eventually work, there it is. And it calculated the same average, which was 62.